Logic is our topic for today, and we have two lovely quotes about logic from the ever-logical Mr. Spock from Star Trek, and if you don't know what that is, oh well. He's a character who has dedicated his life to pure logic. And he says, logic is a tweeting bird chirping in the meadow. Logic is a wreath of pretty flowers that smell bad. So there you go. Two quotes about logic that make no sense whatsoever. Which kind of sometimes describes logic in that it's a little hard to grasp. But we're going to do our best to illustrate and to give examples of the two laws of logic that we're going to be working with and how they work. And we're going to have to learn their names, which is half the battle here. But then we're going to just kind of play with them a little bit. The first one is called the law of detachment. Now before we go any further, let me just kind of pull this out for a second. This P arrow Q. P arrow Q is just shorthand for a conditional statement. If something P, then Q. It's just a little shorthand that we use to symbolize that, instead of writing a whole conditional statement out. But that's what that means. There's nothing magic about P or Q. They're just variables. I could say A arrow B or X arrow Y or whatever I want. I could use Greek letters, alpha, arrow, beta. They're just variables. They aren't anything special. So, if it is a true conditional and P happens, then Q must follow if it is true. One thing about logic and deductive reasoning, truth is absolute. I can make a statement, and if it's false even once, then the entire statement is false. In order for it to be true, it must always, in all circumstances, be true. There's no kind of sort of true, a little bit true, but not really. Well, true for some people, but not for other people. And none of this wishy-washy relativistic truth here. This is absolute truth. Which is why some people like math and logic a lot, because there's absolute truth here, where a lot of other things they have trouble finding absolute truth in life. It's something you can kind of cling to. A little more obvious. And some people like that. So, if I have a true conditional and P happens, then Q must follow. The example, if it rains, then I'll carry an umbrella. It's raining outside. What therefore must happen? Yes. I must be carrying an umbrella. Because I'm told that this is a true conditional. Absolutely true in all circumstances. If it rains, then I'll carry an umbrella, and it's raining outside. Therefore, you may logically conclude that I am carrying an umbrella. That's the law of detachment. If you're making a note card on this, maybe what your note card would look like would be something like this. That would be one side of your note card. The other side of your note card might be, say, if P arrow Q is a true conditional, and get ahead of myself, P occurs, then Q must, emphasis added, follow. So that's side one of your note card, that's side two of your note card. That's kind of the thing that we're looking for on these note cards to help you study from. Because with a note card like this, if I saw law of detachment, I should be able to say what it is. Or if I flipped it over and gave myself this, if P arrow Q is a true conditional and P occurs, then Q must follow, I should be able to say, oh, that's the law of detachment. That's how we study for our vocab. Both ways. But that's why we aren't putting both things on one side or just doing our vocab on a note card, copying it down. We're actually making flashcards. So I have something to study from when quiz and test time comes, which, by the way, is coming pretty soon, early next week. So that's maybe what that note card would look like if you're doing it. So if you don't have note cards yet, get them this weekend. And I've got a lot of people now who are cutting them in half. Take the small note cards and are cutting them in half and just using half note cards. That's fine, because you get twice as many note cards in a pack then. They still only cost about 50 cents, but still. Why spend more than you get to? All right. One thing we have to be careful of is to make sure it is the hypothesis that happens. Because P leads to Q, not the other way around. It's not the converse. P leads to Q. If it's raining, then I'll carry an umbrella. Not, if I carry an umbrella, then it's raining. That's backwards, isn't it? Okay? So if I'm carrying an umbrella, I can't make a conclusion, because I don't know what's going on. Another example of that might be, let's take cars. You guys are, for the most part, sophomores, going to be driving soon. So a lot of people are thinking about cars. So I could say, if it's a Fusion, then it's a Ford. Right? And that would be an absolutely true conditional. All Fusions are Fords. We know that. And you saw a Fusion sitting on the street. What could you conclude? Therefore, it must be a Ford. What if I saw a Ford sitting on the street? Does that mean I can conclude it's a Fusion? No, it could be an F-150 truck or something else, or a tractor, or anything else that Ford happens to make. So you just have to always make sure that you're heading the right direction. That's a hypothesis that occurred, not the conclusion. Don't accidentally work it backwards. Because we know the converse of that, if it's a Ford, then it's a Fusion, is not a true conditional, is it? So we have to be careful with the law of detachment. It's not hard. In fact, it's almost too simple in a lot of cases. You overthink it. There's a note card. Law of syllogism. And again, this could be your note card where this is the front. And this is the back. Law of syllogism, and that's a funny word, syllogism. It really is. But it's a word we're stuck with. The law of syllogism says if P leads to Q and Q leads to R, then P must lead to R. It's the old chain of events. Okay? You've all probably as a child heard the book, if you give a pig a pancake, or if you give a moose a muffin, or if you give a mouse a cookie. Remember those books? Those books are awesome. I love those books. In fact, I almost grabbed one today, and I was going to grab it and bring it in and read it to you today. But my kids have put away all their books from that age, and we don't have them anymore. So I used to be able to go in and just grab them off my kid's shelf and read them. But they're gone. Those days are gone. But that's syllogism. That's the idea behind syllogism, chain of events. Event A leads to event B leads to event C, so if event A happens, event C must also then occur, right? Examples of that. I don't know. Make it something simple. If you read Harry Potter, then you'll want to see the movie. If you want to see the movie, then you'll be disappointed. So if you read Harry Potter, then you'll be disappointed. Okay, I didn't say it was necessarily true, but it's an example of syllogism. event A leads to event B leads to event C, so A leads to C. And sometimes these get ridiculous, like in those, if you give a mouse a cookie books. I mean, you wind up getting ridiculous results. If I go to the football game tonight, I'm going to meet some friends. If I meet some friends, we're going to have a good time. If we have a good time, we might forget to be reasonable. If we forget to be reasonable, we'll probably get arrested. If we get arrested, we're going to go to jail. If we go to jail, we're going to meet someone named Bubba. If we meet someone named Bubba, we're going to get killed. So therefore, if I go to the football game tonight, I'm going to get killed. Okay? So can we get carried away with this stuff? Oh, yeah. We can make huge, long chains of events. The thing is, you want to make sure you don't break the chain, or you don't go in the wrong direction. It's a one-way street. It's not a Y in the road. It's A leads to B leads to C leads to D. And so A goes to D, but not A leads to B, A leads to C, A leads to, okay? It's a chain of events, not a Y or a fork. So you have to be careful. It's always got to be A to B, B to C, C to D, therefore A to D must be true. Not A to B, sorry, forgot the arrow, A to B and A to C. That doesn't mean any relationship necessarily exists between B and C. So a lot of times it helps us to kind of draw out the chain and see where it's at. And make sure that we have a syllogism and not just two unrelated events. So let's identify what's being illustrated here. Law of detachment or law of syllogism. John knew if he got an A in the test, he'd have 4.0. John got an A in the test and got his 4.0. Is that a syllogism or a detachment? That's a detachment. Now, how can you tell? What is it not? Let me ask you that. What is special about syllogism? Syllogism is that, what have I called it? A chain of events? Is it a chain of events or just a single event? A goes to B, A happened, so B also happened. It's just A to B. Same event twice. That's a detachment. If Anne goes to the game, she'll see her friends. If she sees her friends, then she'll have fun. So Anne goes to the game, she'll have fun. That is a syllogism, yes. Good. Let's use the law of syllogism to make a conclusion. Notice we're told which one we're using. So we want to find a chain if possible. If I speed, then I'll get a ticket. If I get a ticket, then my insurance rates will increase. What conclusion can I make? Yes. If I speed, then my insurance rates go up. Yep. Chain of events. This is X. This led to Y. This is the same Y. And it leads to Z, therefore X must go to Z. If I eat sushi, then I'll get sick. If I go to the Japanese restaurant, I'll eat sushi. What do you get? That's right. Now this is a little trickier because if this is X and this is Y, this is not Y, is it? But eating sushi, X is here. And this is like W. So this one went W, X, X to Y. That's okay. That's fine. It's still a chain, W to X, X to Y. What wouldn't be okay is if this is a converse. If it said, if I eat sushi, then I'll go to a Japanese restaurant. That would mean no conclusion necessarily between the restaurant and being sick. So you have to watch that. It has to be a chain, not a fork. Let's look at a couple other examples. And I'm going to pull out our worksheet for today to get some of our other examples. We'll go through some of our worksheet together. What? Oh, did I give this one to you yesterday? I did. I'm sorry. You guys already have it. So let's look at it. Oh, keep it then. Have an extra. Consider it a present. It's Friday. Let's pull that out. You're right. Thank you for reminding me. Because I'd have been short the next hour, and then I'd be wondering why I was short. Make a conclusion. Number one, if you get a hit, then your baseball team will win. You hit a home run. What conclusion can you make? Yes.
Your baseball team won?
Yep, we won. My baseball team won. Number two, if Riley gets promoted, then Kelly will also be promoted. Riley is promoted. Therefore what? Kelly is promoted, yes. Number six, if an integer is divided by one of its factors, then the result is another one of the factors. You divide an even integer x by 2. What can you conclude? Get to a factor of x? Yes, because it's even. Therefore, the result is also a factor. Just what it said in the first statement. It's law of detachment. It's just kind of written a little different. If an integer is divided by one of its factors, the result is one of the integer's factors. You divide an integer x by 2, therefore, the result is one of x's factors. That's all detachment. A leads to B, A happens, B must follow. Let's look at syllogism again. Let's do 8 and 9. If you mail the payment by noon, it will arrive by tomorrow. If your payment arrives by tomorrow, then you won't be charged a late fee. Therefore, where do we start? It's a syllogism, so we start from our very beginning. Yes?
If you mail the payment by noon, you won't be charged.
Yep. If you mail the payment by noon, then you won't be charged a late fee. Start at the beginning, go to the end. Skip the middle stuff. Number 9. If Estelle takes her broker's advice, she'll invest in stock X. If Estelle invests in stock X, she'll earn 50% on her investment by next year. Therefore, excellent, yes. Also, we should all find out who her broker is and invest as much money as possible with that person. If they're giving out advice like that, 50% increase in 1 year? Yes, please. All right, identify. Law of detachment, law of syllogism, or neither. Number 11, if Cedric plays the big game, he'll get nervous. If he gets nervous, then he performs well. Conclusion, if Cedric plays in a big game, he performs well. Is that a syllogism or detachment? Which one is a chain of events? Is it syllogism or the detachment chain of events? Syllogism is chain. Is this a chain? A goes to B, B goes to C? No? Yes, because you can kind of tell because they're two separate sentences, right? Two completely separate sentences, not the same thing happening both times. The same thing's happening both times, that's detachment. If it's two different things, you need to a third thing, that is syllogism. Let's look at 13. If Levon gets money, she gives half of it to Sid. If Sid gets money, he gets half to Levon. Conclusion. Sid and Levon share their money equally. Syllogism, detachment, or neither? Yeah. Neither. Okay. Why wouldn't it be equal? Well, let's think about this for a second. Let's say Levon gets I'll say $48. No, let's not do 48. Let's do $64. So she gives half her money to Sid, which is $32. Sid just got money. He got $32. How much to give Levon? Half of it, 16. Levon just got $16. How much did she give back to Sid? 8. Sid just got $8. How much is he giving back? 4. Who's going to wind up with more money? No, Levon. Levon's going to get more money in the end. So are they sharing it equally? No, they aren't. That's an invalid conclusion. Not to mention it just becomes tedious after a while. Okay, you give me 5 cents, here's 2.5. Well, you give me 2.5 cents, here's 1.25. Yeah, right. Okay? So we've done already half your worksheet. The rest of the assignment is in the book. As far as the vocab goes, for tonight, I just want you to start the note cards. We'll fill them in class. In order to do that, we're looking at the properties of algebra. And you can just write down like reflexive property, symmetric property, transitive property, distributive property. Okay? You can just write those properties down and we'll on one side and we will fill in the properties later. Don't just write the word properties of algebra, write down each specific property on a different note card and then we'll work on getting them filled in on Monday. Got it? Okay. We still have a little bit of work time left today. What do you know? So, you got a few minutes to get this thing going. We already did half the worksheet. You can probably finish that easily and move on to the next.